Hi everyone, we are project number 23086, Electrodose Quantitation of Electromagnetic Pulse Therapy. Our team members are Hassan Al-Rabia, who is also our team lead, and he is a biomedical engineering major. Then we have Goran Shman, who is an electrical engineering major. We have Jiangnan Huang, who is also a biomedical engineer. We have Julio Trejo, who is double majoring in biomedical engineering and mechanical engineering. And finally, we have Zihao Zhang, who is also an electrical engineering major. Here is our poster for Design Day. So studies have shown that PEMF, pulsed electromagnetic field, can help patients with post-intensive surgery pains, chronic muscle and tissue pains, and more. Regenesis Biomedical has created therapy devices that transmit these PEMF fields, which can help patients get relief from this pain. These devices shall undergo clinical testing for confirmation of medical benefits with long-term use and proper administration of therapy dosages. So for the overview of our device, Regenesis has two types of therapy devices. There's a single pad device with one signal being sent out, dual pad device with two out-of-phase signals being sent out. Both are at a 27 MHz frequency. The purpose of our project is to create a compliance monitoring device that will help Regenesis to verify that patients administered the correct PEMF dosage on themselves. And this is necessary for Regenesis' desired medical testing. As for the goals, we are trying to build off of a prior team's project, and our project aims to improve the PEMF sensing reliability, expand on pre-existing circuitry, produce a user-friendly design akin to a watch, ensure proper recording and reporting of administered therapies, and finally, make a more easily manufacturable product.
Now for our system approach, the user experiences therapy through the PEMF therapy device, which our device then picks up, computes a few details, and sends the results through the Bluetooth radio. Now moving on to our approach for the project, we focused on watch-like design for the mechanical system, such that the overall design would be light, slim, and adjustable in size, and have minimal signal interference from the chosen materials, and be easily manufacturable with low costs and easy reproduction via whatever manufacturing methods we chose. Now the electrical system approach compared to the prior team's focus on feasibility, we want to ensure reliability of a strong signal from the surrounding noise, compactness of the circuit to the space administered by a watch-like design, as well as low power consumption for operation from a single coin cell battery. While it was not our main focus, the software approach focused on simplicity, Bluetooth operation, as well as documentation of any code produced. Now moving into the system requirements, here we have our four main driving requirements, the first being frequency accuracy, which required us to get within a 5% margin of 27 MHz for the intended sensitivity. The second being signal quality, which required a clear depiction of the expected signal as reported by Regenesis Biomedical. The third being downscale, which required the mechanical design to be approximately the size of a smartwatch. The fourth being the overall cost of a single unit being under $200. Moving into the mechanical design, this early version of the assembly demonstrates the key components of the overall design, being composed of a bottom casing, a middle, and a top, as well as an acrylic window, rubber strap, and two pins. Here with the case and acrylic window, you can see that there's three key versions that we went through in order to get to our final version. Revision 2 featured a complicated lid interface, as well as 4 screws total to secure the entire casing, and 4 more screws to secure the acrylic window to the casing. Revision 3 used PLA pin points to secure the acrylic window to the bottom of the casing, as well as tried for a snap-on lid approach. Revision 4 combined the middle and bottom case components into one single 3D print, as well as made adjustments to the lid snap-on points and removed the case screws. Now the rubber strap was simple but critical for securing the design to the user, featuring a reduction in size with each iteration. The final mechanical design brought back 2 screw holes just to secure the lid, as well as further reduce the strap size. Here we have the first prototype of our electrical design that features the antenna circuit, and this was used to inform the rest of our electrical design, such that we ended up with 2 boards, a top board and a bottom board. Top board contains the microcontroller, LEDs, and anything else that is not directly related to the antenna itself. The bottom board has the antenna, rectification diodes, operational amplifier, and capacitors, most of which are geared towards sensitizing the antenna to specifically 27 MHz. Moving into the software, we wanted to start by testing our microcontroller using the basic LED blink test written on the screen. For our full functionality implementation, we moved into the Bluetooth and analog to digital converter code as seen on the screen. Going into the system requirements, we primarily focused on the electrical assembly. However, the mechanical assembly was not ignored, it was simply a bit easier to accomplish in comparison. So the electrical assembly primarily focused on the antenna itself as to what signal it was picking up and the clarity of the signal it was picking up. And the mechanical assembly focused on the watch design and incorporating everything into that set space and making sure that most of the components are good insulators or hardly conductive.
Moving on to our results and deliverables. Here's a breakdown of our purchases. We had a total budget of $4,000. So far we've spent around $1,100 and have around $2,900 remaining. As for our customer deliverables, we have a final report that we need to submit to our sponsor and our mentor in a writing report format. Then we have our customer satisfaction report, which will also be delivered to our sponsor and our mentor in the form of a written report. And finally, we have our Quantitation of electromagnetic pulse therapy device that will also be sent to our sponsor and the mentor in the form of a final product. As for the future directions that this project could go into, we recommend the development of a Bluetooth communication app that will help our company to store their data for the testing. We recommend the finalization of the electrical design by approximating the capacitor rather than using an adjustable capacitor. We also recommending the employment of a rechargeable battery and charger system and compression of the design further. And finally, we recommend the finalization of the mechanical design, which will include the shrinking the design to match the electrical design and an input slot for the recharge interface. Thank you.